Hi guys, in this video we're going to be using a tool called Desmos to do linear regression. We've talked about scatter plots already, and here you can see I have a scatter plot with some data on it. We can see a nice positive correlation on this, and we said that we use scatter plots to make predictions. So in this case what we're going to do is we are now going to go into some of the deeper technique for how to get the exact correct line through this data that we can use to use predictions. And this process is called linear regression. So we're going to use Desmos to do the heavy numerical lifting for us to create the exact proper line through here that's going to give us our best predictions for the future. The way this works is when you get your copy of this Desmos tool, you won't have any data here where it says x1 and y1. This will be a blank table, and whatever data you're wanting to do a linear regression for, you simply type that data into this over here, and what will happen is it will automatically create the line for you. So again, all you're responsible for is you type the x and y data into the table. And you'll probably have that on hand. You'll be given that in the problem. And once you have typed in that data, we're going to look down here. And this is what's called our regression equation. And I'm going to go ahead and put that line on there. Desmos will automatically do this for you in the tool that I'm giving you. Once you put in that data, all we have to do is know how to analyze that data. So the first thing we need to find is the equation of this line. So it's in slope-intercept form, y equals mx plus b. And as you plug it in, Desmos will tell you what m is. M in this case is 4.319, and b will be 35.046. They will be messy, they will be ugly. This is okay. That should not be a problem at all. So this has given us the equation of this line, the line of best fit that passes through this data that I put in here. So the equation of this line is y equals 4.319x plus 35.046. And now I can use that equation to make predictions based off of what x is. The other part of this that we need to be aware of is the r value. The r value tells us how well our line fits to our data. A perfect fit, that is if our data was perfectly on the line, would yield an r value of 1. And the farther away an r value is from 1, the less good the fit is. So here you can see the r value is 0.723. So anything over 0.5 is a pretty decent fit. So for our purposes here, that's a pretty good fit. If you want real excellence, would be somewhere in the area of 0.9, but this is as good as we're going to get on this. So the r value is 0.723. A positive r value indicates a positive correlation. A negative r value would indicate a negative correlation. And again, the closer to 1 the r value is, the better our line of fit is. So again, to find your equation of the line of best fit, all you have to do is plug the data into this. It's going to give you this equation. So now you can write the equation of that line. And this r value is going to tell you how well that equation fits the data. We want it to be close to 1. And then once you have this process and you're used to finding this equation and understanding what the r value means, then what we can do is we can go on to use that equation to make some predictions.